The technology we're applying to this important challenge is called the magneto-inertial technology. The overall solution leverages a device, a small, lightweight, ankle-worn device that embeds a number of sensors. It also leverages a smartphone, so the device is paired via Bluetooth to a smartphone. The smartphone sends the XYZ information to the cloud over the air and is stored on servers. And then we have a web application accessing the servers, and remote personnel can monitor in real time and track the position of the first responders.
So you can see what we have here is an NVIDIA processing system, and then we have a battery pack in the back, and then there's a USB cable going to our camera. These are really the only three requirements for a system like this, and it has a world-class localization algorithm. So the first responder or any user, all they have to do is turn this on, put it on their head, and just walk around, and you could walk miles and come back to the same spot, and the localization would not be thrown off by that much. So it's really a ready-to-go system.
Currently, fire chiefs utilize command boards and radios to best manage an incident. Our platform allows the command staff to consolidate and manage all data on the fire scene. The command staff can zoom into the scene to get more information, including a generated floor plan utilizing outside imagery of the structure. Once the floor plan is generated, firefighters use helmet and boot-mounted sensors to localize and verify the floor plan within 1 meter accuracy. The command staff can also monitor a stream of thermal imaging cameras, air levels, biometrics, health, toxicity, and movement in real time. This information can help the chief take control of Mayday situations. Additionally, we offer the incident commander accountability management, task lists, and consolidated report out of all information on a single platform.
Shine is the first positioning system to use artificial intelligence for accurate tracking beyond GPS. The AI engine models human movement to achieve unparalleled accuracy. Its rugged design and game-changing features are suited for the most challenging environments. We are convinced that Shine will completely transform incident handling and outcomes.
Nav4U, a startup spin-off of the Geoloc laboratory in France, initiated Charlie Project in order to secure and optimize first responders' interventions. The company uses innovative algorithms merging inertial, magnetic, and GNSS data to determine the user's position with a foot-mounted device. Our algorithms include an artificial intelligence model allowing to detect a wide variety of human movements. We are also able to exploit GNSS measurement, even degraded and indoors, to correct velocity estimation. Here is the architecture of the complete solution. The agents in intervention are equipped with a foot-mounted location device and possibly with a user application that is not mandatory but offers more features in some scenarios. The data is transmitted to a communication gateway near the unit manager, allowing him to follow the movement of each agent through a supervision software offering a wide range of services. The data is also stored in a server to perform post-intervention analysis and optimize deployments.
Each firefighter carries a small wearable tracking beacon. Firefighter can also drop additional anchors on areas of interest to tag, for example, stairs, source of fire, victims, and hazmat, and these are visible to the incident commander. If IC makes any mistake in giving direction to firefighters, he can see them going in wrong direction and quickly correct himself. In a most dreaded scenario of firefighters inside declaring Mayday, the situation gets very tricky. In the traditional sense, with no visible location information, the incident commander can only rely on a reactive mode to try to find location information. However, with Track.io, the location of firefighters is always known on GUI. The commander can direct other firefighters to Mayday Firefighter,
Bank 3's first responder tracking system combines ultra-wideband RF tracking tags with AI-enhanced IMU position estimation. Our UWB anchors are installed on a vehicle and can track responders in 3 dimensions with an accuracy of less than a meter. When the UWB tags are out of range or obscured by grade or multiple walls, our IMU tracking takes over. Traditional IMU tracking falls apart very quickly due to noise and error in the IMU itself. But by feeding the raw IMU data into our machine learning model, we are able to get clean output positions from a small, low-cost device.
Our solution to track the 3-dimensional position of firefighters and first responders is to use enhanced inertia sensing technology. We have developed proof-of-concept prototype. It is this device. This device integrates microcontroller and inertia measurement unit. We have demonstrated that this device can produce real-time position information of its user in indoor environments without using any external signals.
While responding to emergencies, first responders, just by typing in an address, can see the internal layout and floor plans, and most importantly, can now be tracked up to 1 meter with 0 latency, just by having their smartphones in their bunker gear, front pocket, or pants.
Our product features two groundbreaking components, the first being tracking, the next being mapping. Our tracking technology tracks first responders within 10 centimeters of air, and our mapping technology builds a very vibrant map of operators' indoor locations. Our tracking technology can be overlaid with our mapping technology to give support teams and first responders a really good idea of where they are in relationship to their environment. Both of our modules, our tracking and mapping modules, they're interoperable with a lot of other different technologies out there. So if you're looking to partner in future rounds, we're certainly down for it. And we believe that the value that our equipment brings and the value add it does for safety can really make it the industry standard in the not so distant future.